Homework 7, number 8. So use MATLAB to solve the following systems of equations. So again, as we discussed during the lecture when we were dealing with systems of equations, you can solve a system of equation by basically arranging your coefficients in one matrix and then arranging your right-hand side numbers in another matrix, and then using the backslash operator to solve these equations. Okay, so let's take note of the first equation. So x plus 8y equals 7, and 2x minus 8y equals minus 3. So let's go to MATLAB and start working on this. So let me clear everything and let me put a comment here. I'm gonna say x plus 8y equals 7, and then my second equation will be 2x minus 8y equals minus 3. 2x minus 8y equals minus 3. Okay, so these are the two equations. So in order to do this, let's first of all, let's try to solve it by hand, just to make sure that the numbers we end up getting make sense. So if I add these two equations, I'm going to end up with 3x is equal to 4, right? X plus 2x is 3x, plus 8y minus 8y is 0, 7 minus 3 is 4. So x, I should expect x to be 4 divided by 3, right? And if x is equal to 4 divided by 3, then y will just be, it will be 7 minus 4 divided by 3, right? So it'll be 7 minus 4 divided by 3, and then I'm going to divide this number by 8, and b should be 0.7083. So these are the numbers we should get if our approach is correct. So in order to approach this, you need to create a matrix containing the coefficients. So I'm going to call this matrix capital A, and it's going to have the coefficients. So for this first equation, I have 1 and 8. These are my coefficients for the first equation, and then I'm going to use a semicolon to move to a second row, and on the second equation, these are my coefficients, which are 2 and minus 8. So this is my matrix of coefficients here, 1, 8, 2, minus 8, and then I need to create a column vector with the right hand numbers, right? With the right hand numbers. So in this case, it's gonna, let's call it B, and B will be column vector containing 7 and minus 3. So I'll have 7, I'm gonna use the semicolon to move to a new line, minus 3, and here we go. So these are my two elements I need to solve the system of equation: the matrix containing the coefficients and vector containing the right hand numbers. So now in order to solve this, I'm gonna basically let's create, I'm gonna just go A backslash B, and you should get the numbers here. First number corresponds to X, second number corresponds to Y, and this is a solution for this system of equations. And let's go and check if they match what we got. Yeah, so 1.33 and 0.708, it does match. So this is the approach we're going to use. So let's do the same thing for B. So B, in this case, I have a bunch of equations. I have x plus 3y minus 2z equals 5. So let me show it here on the screen. 3x plus 5y plus 6z equals 7. 2x plus 4y plus 3z equals 8. Okay, let's go back to MATLAB and just create our two matrices, right? So I'm gonna clear, and then I'm gonna create, first of all, my matrix of coefficients, and again I'm using capital A to do so. And let me go back. So I have x plus 3y minus 2z. So it's going to be 1, 3 minus 2, 1, 3 minus 2 for the first equation, semicolon to move to a new line. My second equation is 3x plus 5y plus 6z. So it's 3, 5, 6, 3, 5, 6, semicolon. Move to a third equation, 2x plus 4y plus 3z. So it's 2, 4, 3, 2, 4, 3. This is my matrix of coefficients, and then I'm going to create my column vector with the right hand numbers. So in this case, let's keep on using the same terminology, b. And b will be equal to 5, 7, 8. Right, similar to what's asked in the prompt. Where's MATLAB? Here we go. I'm going to have 5, semicolon, 7, semicolon, 8. And again, to solve, you need to just divide a by b. Boom. These are your solutions. So the first one is the x value, second one is the y, third one is the z. Okay, now let's do number C. Okay, let's go back to the question. So for part C, again, 3 equations. So let's try and do it. So let's navigate back to MATLAB and just create our matrix of coefficients. Okay, so I just clear CLC so that I don't overwrite any old numbers. I'm gonna create A will be 2, 1, minus 1, 2, 1, minus 1 for the first equation, semicolon. Minus 3, minus 1, 2, minus 3, minus 1, 2 for the second equation, semicolon. Minus 2, 1, 2, minus 2, 1, 2 for the third equation. So I have my matrix of coefficients, and then I'm going to create my column vector B containing the numbers on the right hand side. So in this case it's 8 minus 11 minus 3. So I have 8 semicolon minus 11 semicolon. Is it 3 or minus 3? It's minus 3. Minus 3. Here we go. And then to solve this, to solve a system of equations, I'm just going to go A backslash B. And you're going to get the solution. So x is equal to 2, y is equal to 3, z is equal to minus 1. Okay, so this was part C. Now let's clear the memory, clear the screen, start fresh. Let's go back to the document and see part D. So for part D, you're given 4 equations with 4 unknowns, right? So you have A0, you have A1, you have A2, and then you have A3, which is, stuck right here. A3. Okay, so now let's try to do this in a logical way, right? And again, when arranging our matrix, so the trick here, or the hard part here, is just making sure you're structuring your equations properly. So let me go back to MATLAB and let's start writing the matrix of coefficients. So let me write a comment, matrix of coefficients, and it's going to have the order of A0, A0, A1, A2, A3 for each equation. Okay, so let's call it A, and then I'm going to go back to my homework document and just have a look. So for the first one, A0 is 1, A1 is 1, A2 is 1, and A3 is 0, right? So let's write the coefficients for the first equation. We said 1, 1, 1, 0, semicolon. Now let's go back to the homework and look at the second equation. A0 has a coefficient of 1, A1 has a coefficient of 2, A2 has a coefficient of 4, and A3 has a coefficient of 0. So let's go back to to MATLAB. So it's going to be 1, 2, 4, 0. Then I'm going to go to the third equation. Let's have a look here at the prompt. A0 has a coefficient of 1. A1 has a coefficient of 0 because there is no A1. A2 has a coefficient of 9. And A3 has a coefficient of 3 right here, right? So my matrix coefficients is going to be 1, 0, 9, 3 for the third equation, right? So let's go to MATLAB and write this. It will be 1, 0, 9, 3 for the third equation. Semicolon. Let's have a look at the fourth equation. Let's go back to the homework prompt here and have a look. And so for this one, my coefficient for A0 is 1. My coefficient for A1 is 4. My coefficient for A2 is 16. And coefficient for A3 is 0. So let's write this in MATLAB. So it's going to be 1, 4, 16, 0. 1, 4, 16, 0. So this becomes my matrix of coefficients here. And now let's create the row vector with the numbers on the right hand side. Let's go back to the prompt and see what these numbers are. So there'll be 1, 3, 3, 5. Okay, let's go to MATLAB and just write 1, 3, 3, 5. 1, 3, 3, 5. Nope, I want it to be 1, 3, 3, 5. Here we go. So this is my row vector. Now to solve it, I'm just going to use the same operator, a backslash b, and you're going to get this solution for this system of equations. A0 is minus 1.6, A1 is 3, A2 is minus 0.3, and A3 is 2.556. So this is how you solve a system of equations. You need to find your matrix of coefficients. You need to get your column vector for the numbers on the right hand side, and then you use the backslash operator to solve for your unknowns.